सो हेलो माय डियर स्टूडेंट्स। तो लो फिर आ गए आपका टीचर अभिषेक एंड वी आर बैक विथ अ वेरी इंटरेस्टिंग सीरीज, वेरी न्यू थिंग ऑन द यूट्यूब. So this is a playlist where I am sharing each and every topic of grade ninth and 10th. And this series is particularly about grade ninth. सो कोई भी स्टूडेंट जो साइंस में जिसे लगता है कि मुझे कुछ प्रॉब्लम्स है, कुछ वीकनेसेस है और कुछ टॉपिक्स रह गए क्लास में नहीं हो पाए, सो दे कैन एक्सेस दिस सीरीज. दे कैन गेट all the understanding of each and every topic of grade 9 साइंस. सो चलो स्टार्ट करते हैं सेशन को. सो आज जिस टॉपिक के बारे में हम बात करने वाले हैं वो टॉपिक कोई ऐसा टॉपिक है जो हमें इस अर्थ पे रोक के रखता है, दैट होल्ड्स आवर मास ऑन दिस अर्थ. इट्स अ काइंड ऑफ फोर्स. Well said, well said. Everyone is guessing it right. We are talking about gravitation. Gravitation is a very important topic if we talk about grade ninth perspective, or if we go beyond ninth and we choose in science, physics and chemistry, then also we will deal with gravitation in grade 11th. Okay, so that is why it's a very important topic. तो लो आपके सामने आने वाला है ग्रेविटेशन का topic by topic explanation. So let's start this session. Now I am sharing my screen with you. Everyone can see my screen. Okay, so in today's topic, we are going to talk about the full grade ninth CBSE syllabus. Okay, and in this series, we will be covering all the topics of science. And this is a series which you can get on my YouTube channel, that is Teach AR. Yeah, if you read it, it is teacher actually. Okay, so yes, the name of the series is Teach AR. Okay, so let's start this session. So the topic that we are starting is gravitation. So आपको साइड में एक पिक्चर दिख रही है दैट देयर इज अ पर्सन सिटिंग अंडर द ट्री. आई होप एवरीवन इज क्लियर हु इज ही. He is Sir Isaac Newton, who coined this term gravitation. Now you might be thinking, sir, what's something amazing that he did? So basically, everyone noticed the falling apples, falling things on the surface of Earth, but no one coined this term gravitation. So hats off to Sir Isaac Newton, who just introduced this topic, and he just gave a theory about this force of gravitation. So what is this force of gravitation? If we talk, gravitation is a attractive force. It's a kind of attractive force, as you can see over here. It's a force of attraction. Like many forces, like magnetic force and electrostatic force, they can be attractive as well as repulsive. But gravitation is a attractive force between any two body in this universe. That means if any body is there in this whole universe, you know that universe कितना बड़ा है, कितना large है. तो कोई भी ऐसी दो बॉडी जिसके पास अपना मास है, ओके, वी कैन से अ बॉडी हैविंग इट्स ओन मास, दे विल attract each other, and that force is called gravitational force. Okay, so you might be thinking about, sir, can everybody attack each other? Yes, definitely. If I talk about this pen, and if I talk about myself, yeah, so this pen is also attracting me and I am also attracting this pen. Okay. But you might be thinking, sir, we cannot see that whether you are attracting it or whether the pen is attracting you. Okay. So definitely gravitational force, how much force is applied, on what factors does it depend? We also need to learn about that. So let's move ahead about this whole series, the whole session. What topics we are going to cover? We are going to cover the universal law of gravitation, which is again a very important topic. Okay, that is being asked in exams also. Importance of law of gravitation, then free fall, mass and weight of an object, and yes, at last determining the value of g, the small g. Okay. सो सारे स्टूडेंट्स जल्दी से एक बार इस वीडियो को शेयर कर दो, ताकि आपके जितने भी फ्रेंड्स हैं जिनको भी इस टॉपिक में प्रॉब्लम है, ओके, वो सारी प्रॉब्लम्स झट से दूर हो जाए. सो लेट्स स्टार्ट विद द फर्स्ट topic, that is universal law of gravitation. If I will read it, every object in this universe attracts every other object with a force which is directly proportional to the product of their masses, okay, and inversely proportional to the square of distance between them. If I go line by line, then you will say, sir, samajh nahi aaya, right? So let's take a situation. Suppose there are two masses. Okay, one is two masses or two objects. You can say object one and object two. Object one has a mass of m1 and object two have a mass of m2. And the distance between their center is, you can also see, this is the center of object m1, m2. The distance between them is r. Let us take the distance between the objects be r. So I can say the force of gravitation, okay, the force of gravitation is directly proportional to the product of their masses, that is m1 multiplied with m2, m1 into m2, and it is inversely proportional. What does this inversely mean? Inversely means ulta, right? Inversely proportional to the square of distance. What is the distance? R is the distance. So it's inversely proportional to the square of distance between them. Now, if this question comes in your exam, you can write the statement. You can show that figure of two masses. Okay. And both of the object will attract each other with the same force. Here we have written F2 and M2. That means the force with which this first mass would be attracted, and F2 means the force by which this second mass is attracted towards the first mass. Okay. So if we have already studied about second law of Newton's, okay, Newton's second law, that is F is directly proportional to ma. Then if we want to remove this proportionality, we always use a constant. Over there, the value of constant was 1. Okay. So similarly, we are also going to remove this proportionality. And to remove this proportionality, we will use a constant. So F is equals to G. What is this G? I will come to it later. M1 multiplied with M2 upon R square. Now, this is the expression that we derive for the gravitational force acting between two bodies. Now, the force that F1 will apply on F2 will be equal to the force that F2 will, that mass M2 will apply on mass M1. Okay. That means we have already studied about the third law of motion, or the Newton's third law. Okay. That every action have a equal and opposite reaction. So if one is attracting 2 with F2, then 2 will also attract 1 with the same force. So for both the body, the force experienced would be calculated by using this expression. So this is a very important expression that will help you throughout this journey. Okay. Now, what are the different things that we are talking about here? F is what? Force of gravitation. Okay. Gravitational force. Okay. Or I can also write it like F, and then there is a small g underscore. And then m1 is the mass of first object, m2 is the mass of second object, r is the distance between their center or between the bodies. Now, what is this g? So this g is called universal gravitational constant. Now, you already know that every constant have its fixed value. So what is the value of g? So g का value है भैया, देखो, 6.67 into 10 to the power minus 11. Now you might be thinking, sir, what is the unit of G? Come on, let's derive the unit of G. I have already uh, told you in many of the classes that how to derive the unit of G. What is the force? What is the unit of force? Yes, Newton. Okay. What is the unit of masses? Kg, and there are two masses, so I will say kg square. And what is the unit of distance? Meter. And there is a square of distance, that means meter square. So come on, put everything over there. If we use the same formula, if we use the same expression, we can say G is equals to F multiplied with R square divided by M1 and M2. So we can say force Newton, R square having the unit of meter square, and M1 and M2. They are kg square, but they are in reciprocal. So I will write it like Newton meter square per kg square. So if anyone asks you कि बताओ भाई ग्रेविटेशनल कांस्टेंट का यूनिट क्या है, so Newton meter square per kg square. And what is the value? The value is written over here. That is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. So this is the universal law of gravitation. You can also have a look. How does it look like? Okay. And the expression that we got is over here. Okay. Let's move ahead. Let's do some question related to the same topic. Okay. So this is question number one. Oh, I'm reading the question. A body of mass 1 kg is placed, suppose this is the body of 1 kg, is placed at a distance of 2 meter from the another body with mass 10 kg. Okay, this is a bigger body with 10 kg mass. And what is the distance between them? Distance between them is 2 meter. Yes. Okay. At what distance from the body 1 kg and another body of mass 5 kg would be placed so that the net force of gravitation on the body of mass 1 kg is 0? Okay. Now first, I think this is a quite good question, and it's a very conceptual question. But first, we need to find out the gravitational force between both the bodies. So you already know that this 10 kg mass will pull this 1 kg mass, and this 1 kg mass will pull or apply a attraction force on the 10 kg mass. So we have to find out that force. G M1, use the expression M2 upon R square. Now we are going to put the values of all the things that we know. G is 6.67 into 10 raised to power minus 11. Okay. Mass of the object is, first mass is 1, second mass is 10. Okay. What is R square? R is 2, so square of 2 is 4. Yes? Okay. Come on, let's do this. So, though the calculation would be a difficult thing that you have to do, okay, but it's not impossible. Come on, let's do it. If we will divide these two numbers, okay, we will get 1 point. Come on, let's do this. 2, 6, 1.66. Yeah, 1.66. And then there is 10 raised to power minus 11. Okay, 10 raised to power minus 11 over here. And also there is 10 raised to power 1. This is 10 raised to power 1 actually. So we got 10 raised to power minus 10. Okay. This, and what is the unit of force? Everyone knows that? Yes, the unit of force is Newton. So how much force is being applied on both the objects? Okay. So both the objects will attract each other with the force of 1.66 into 10 raised to power minus 10 Newton. That's great. Now, the additional question is that where should we place the object? There's one more object that we are talking about. Where should we place another object of 5 kg mass? How much mass? Of 5 kg. So that this 1 kg body will experience zero gravitational force. So if you want to see a body which does not experience any net force. That means the forces applied on it is either equal in both direction, equal and opposite, then only it will not experience any net force, right? How much force this 10 kg mass is applying on this 1 kg mass? Just we have just found it. Yes. And if we will apply a similar force on this object, on the other side, on the opposite side, what would be the net force? Yes, zero. That means this 5 kg mass should also pull the object with the same force. So can I write that this was the force F1, let me consider it F1 that is applied on 1 kg mass by 10 kg, and let this be F2. So if we want the net force to be 0, F1 and F2 should be equal to each other. Okay. That means F2 would be also equal to 1.6 into 10 raised to power, okay, 1.66 into 10 to the power minus 10. Okay. Now we know the force. We know the two masses, 5 kg and 1 kg. We have to find the distance between these two objects. Okay. Come on, let's use the formula. M1, M2. Now this time M1 is 1 kg, M2 is 5 kg, and the distance we don't know, we have to find it. So let's do this. We will put the R square over here and we will bring that force down. So 1.67 into 10 raised to power minus 11 into 1 into 5. Okay. And divided by the force, that is 1.66 into 10 to the power minus 10. Can I say that these two numbers could cancel each other if we do a quick approximation? Approximately they are equal. So yes. And what about this? Can you see over here? This is 10 raised to power minus 10. This is 10 raised to power minus 11. They are both in division, right? So if they are in division, that means we have to subtract their powers. Okay, so come on, let's do it with me. What we have is, what we have is 5 over here and 10 to the power minus 11 minus of 10. Okay, what is this minus and minus? It will become plus. So we can say 5 into 10 to the power minus 1, that is equals to 0.5. Getting it? So 0.5 is the answer for r square. If we want to find the value of r, we have to do square root of 0.5. Okay. So r is equals to 0.5 meters. Okay. 0.5 meter. Now, let's move ahead to the next question. Okay. So this is question number 2 that we are doing together. Read the question first. I'm reading it for you. The gravitational force between two objects is F. Okay. Suppose if there are two objects, okay, M1 having mass M1 and M2, okay, and the force of attraction between both of them is F. Okay. How do we represent that F? And also the distance between both of them is R. Okay. So how do we represent this F? We represent it as G M1 M2 upon R square. So this is the force that is acting between two objects. Okay. How will this force change? If you reduce, when the distance between them is reduced to half. Okay. That means you are making the distance half. Now that means you are bringing the objects closer to each other. Okay. and you have reduced the distance to r by 2, that is half. Okay. Is there any other change that you are doing with this? नहीं, कोई चेंज नहीं कर रहे हैं। तो अभी हमने पढ़ा है कि जो फोर्स है वो डिस्टेंस के स्क्वायर के इनवर्सली प्रोपोर्शनल है। इसका मतलब क्या है? इसका मतलब है कि इफ डिस्टेंस इज इंक्रीज्ड, if the distance will increase, the force would change, the force will decrease square times. Okay, that means कि अगर हम डिस्टेंस को डबल कर दें, अगर डिस्टेंस को डबल कर दें तो डिस्टेंस 2r का स्क्वायर, डिस्टेंस 2r हो गया, और इसका मतलब कि जो फोर्स होगा वो 1/4 हो जाएगा, 1/4 ऑफ द ओरिजिनल फोर्स। गेटिंग इट? नाउ इन दिस क्वेश्चन, the question says that the distance has been reduced to half. Come on, let's find the new value of f. So let's say f new, okay, is equals to g. M1, M2, no change has been done here, but the distance has been changed to half. That is r by 2 whole square. Okay. Come on, let's simplify this. G M1 M2 upon r square by 4. Now, you already know about, according to the rule of fractions, this 4 will also go over here. Now, can you see something? We have got something familiar over here. What was this? This was the original force that we were talking about earlier. Yes? So, this is what? The new force will become 4 times the original force that was acting before. That means now the force will become 4 times. So, what we will say? Force will become 4 times. Okay. Yes. Now, the second scenario. Okay. In this second scenario, you can see that the mass of each object is quadrupled. What does this quadrupled means? Okay. Quadruple actually means when the mass becomes 4 times. Like double means 2 times, triple means 4 times, quadruple means 4 times. So mass यहाँ दोनों masses m1 और m2 दोनों, they have now become what? They have now became bigger. 4m1, 4 times m1, 4 times m2. Is there any change in the distance? No. The distance is same. Okay, that we had earlier. Now what will happen? What will be the new force of gravitation? So new force will depend on g, masses of the object. So now the mass is 4m1, another mass is what? 4 times m2. Okay. What is the distance? Distance is same. Come on, let's simplify this. G, this is 4m1, 4m2, 4 and 4 will multiply with each other. Can I say that 16 G m1 m2 upon r square? Agree? Now here you will find something which we have already written somewhere. Come on, come on. What's that? So basically, can you see here? This is the force that was acting earlier. That means it is F. So this new force is 16 times the force acting earlier. So what will happen in this case? In this case, I could say that the force will become 16 times. Force will increase 16 times. Okay. So yes, if the distance is reduced or if the mass is increased, definitely the force of gravitation will also change. Getting it? I hope everyone is understanding. Yes, you can give it a like if you understanding this concept. Okay, let's move ahead. So the next topic is, what is the importance of universal law of gravitation? Before discussing it, can you tell me where do you observe this gravitational force? First, I would like to say that in our solar system there is sun, And why all the planets revolve around the sun? Why our Earth revolve around the sun? Because it is actually being pulled. It is actually being attracted by the sun's gravitation. Okay. Sun is actually applying what? Sun is actually applying gravitational force on Earth, and due to which the Earth is not able to escape out of the range of the sun. That is why always our Earth rotate. Not only Earth, all the planets, भैया सारे planets rotate क्यों कर रहे हैं? क्योंकि sun उन पे gravitational force लगा रहा है. Getting it? Now, next thing is about our moon. Moon, this is Earth and this is our moon, suppose. Moon is also revolving around us. Yes. So moon is also being binded, or you can say is also bounded to move in this path due to the gravitational force applied by Earth. Earth is also applying a gravitational force. Yes. And due to which it is revolving all around the Earth. Okay. Now, the question is that what is the importance of this universal law of gravitation? So basically, you can also see that this gravitational force binds us to Earth because, yes, we also have mass. Okay. And our mass is also being attracted by the Earth. So it also helps us to be on the surface of Earth. Yes. This gravitational, the universal law of gravitation also explain the motion of moon around the Earth. I have already told you that. Then the motion of planets around the sun is also just because of this gravitation. Okay. The tides due to the moon and sun. Okay. You know about the tides? There are some tides in the ocean currents. Yes. Water tides. Okay. This is due to the phenomenon of gravitation because Earth is being attracted by sun also, moon also. Okay. So when forces applied on an object, it will give it a motion. It will give it a acceleration. We have already started in previous chapters, right? Come on. So this is these are some important points, or these are some importance of universal law of gravitation. Okay, let's move ahead. Let's do a question related to Earth and Moon. Okay, so third question. I will suggest everyone please focus on these questions because questions in gravitation chapter इतने आसान नहीं हैं. We have to do a lot of calculations. Okay, so let's talk about this question. The mass of Earth is, my God, what is that? Yes, the mass of Earth is 6 multiplied by 6 into 10 raised to power 24. If I write it over here, 1, 2, 3, 4, I need to do like 24 zeros after that. This much heavy our Earth is. Okay. Now let's talk about the mass of Moon. Mass of Moon, okay, is 7.4 into 10 raised to power 22. It is also heavy, but less than Earth. Definitely, we know that. The distance between Earth and Moon. Come on, let me just make a diagram, a figure. Let's suppose this is Earth and this is Moon. Okay. This is its center. This is its center. So the distance between the center of Earth and Moon is 3.84 into 10 to the power 10 to the power 5 kilometer. Okay, this much kilometer. Now we have to calculate the force exerted by Earth on Moon. Okay, let's find it with the formula that we got. We got F equals to G m1 m2 upon r square. So basically, what is m1 over here? M1 is the mass of Earth, or you can say the mass of Moon. Whatever you want to take, you can take it. M1 is the mass of Earth. G is gravitational constant. Let's put its value. Okay, let me write it over. G, M1 is mass of Earth, M2 is mass of Moon, and R is what? Distance between Earth and Moon. Okay. Let's put the value 6.67 into 10 to the power minus 11. I hope you have learned the value of G till now. Okay. So mass of Earth is 6 into 10 to the power 24. Mass of Moon is 7.4 into 10 to the power 22. Upon what is the value of R? Yes, 3.84 into 10 raised to power 5. But it is in kilometer. So if we will convert this into meters, come on, we will do multiplication with 1000. That means 10 to the power 3 more. So 5 and 3 will together make how much? Will together make 8. And after this, we have to do the square of this value. Okay. So definitely this is going to be a lengthy calculation. Okay. So let's do it over here. Okay. So I will write down. First, let's arrange all these exponents. Okay. So force is equal to 6.67 multiplied with 6 multiplied with 7.4 divided by 3.84 into 3.84. Why two times? Because we have to do a square. Okay. Then multiplied with 10 raised to power minus 11 into 10 to the power 24 into 10 to the power 22. Okay, is that so? Yes. 22. Yeah. And after that, on the bottom, on the denominator, we have 10 to the power 16 because we have squared it. So 8 times 2 is 16. Now, come on, let's solve it. Okay, if I look at this is approximately twice, like 7.4 is approximately twice of 3.84. Approximately, not exactly. Or we can also, if you want to multiply, you can also multiply them. Okay. So if you will multiply with 6.67 along with 6, okay, along with 6, that would be equal to, wait, let me just do the multiplication. You can also do the multiplication. So you can say 6.67 multiplied with 6 and then multiplied with 7.4 is equals to 296.148. Okay. And then we have to divide this number with 3.4 and again 3.4, right? That is 25.6. We are getting it as 25.6. So this is some calculation that you have to do. Okay. If I calculate this part, okay, it is the value of this. Now after that, 10 raised to power minus 11. Let's, because if they are in multiplication, if their bases are same and exponents have different powers, if they are in multiplication, then minus 11, we have to add the powers. And then there is 10 raised to power 16, which is in division. So if it is in division, we will do subtraction of the power. So 11 minus 22 is 11, 11 plus 24 is 35, 35 minus 16 is 24. So can I say 25.6 into 10 raised to power 24 24. This is the answer for your. Okay, wait. Let me just check the calculation. This is 46. 46 minus 16 is 30. 30 minus. Okay. No, this is 10 is power 29. Getting it? So this is how we do. And what is the unit? Yes, force is always expressed in Newton. So this is the force between Earth and the moon. Okay, if you want to write it in scientific notation, you know that scientific notation will always have the decimal after the first place. Okay, so 2.56 into 10 to the power 30. Okay, Newton. This is how we got our answer. I hope everyone is getting it. Now, my question is that is Earth and Moon both? Is Earth and Moon both applying equal forces on each other? Yes, definitely. They are applying equal forces on each other because every action have an equal and opposite reaction. Now you might be thinking, sir, then why uh, Moon moves around the Earth, but why does not the Earth moves around the Moon? Because you know that mass of Earth is very much higher than the mass of Moon. And you already know from the second law, Newton's second law, that F equals to ma. If we apply same force on both the objects, okay, the acceleration of Earth would be less because the force is divided by the mass of Earth. And the acceleration of Moon would be more than Earth because its mass is less. The more the mass, the less the acceleration, and the less the mass, the more the acceleration. Okay. So this is the reason behind it. This is also a question. Yeah. Oh, we got the same question now. The Earth and Moon are attracted to each other by gravitational force. Does the Earth attract the Moon with a force greater or smaller or same? Okay. With which the Moon attracts the Earth. Why? Yes, because the Earth and Moon are attracted to each other by gravitational force. The forces are same. Force applied is same. And what is that force? That force is G mass of Earth multiplied with mass of Moon divided by distance between them. Okay. S- Force is same, but their movement cannot be same because Earth having more mass and Moon having less mass. Okay. Okay, let's move ahead. We are here. Oh wow. Can you see the person what he is doing? Skydiving. Oh. That means when you do skydiving, you just fall off the plane or anywhere and you just go down, keep your body free, and you just fall down. Yeah, don't say that we don't have parachute. Yeah, you have the parachute. Okay. Now, if anybody falls down, which force is actually bringing him down? Okay. You have seen people doing skydiving in videos or anywhere else. So, what pulls them? You can say that Earth pulls them, and any object which is on the surface or above the surface of Earth wants to pull it. Okay. And also, the object is also pulling the Earth. If you are in the air, if you are doing skydiving, you are also pulling the Earth, but your force, but Earth will not be affected by that force. Come on, let's see. How much force is that? So, suppose if there is an object of mass 10 kg, okay, on the surface of Earth. Okay. So, from where we will measure this? Okay, the next topic that we got is free fall. It is clear from the word that something is falling, and free means freely falling. So the falling of a body from heights towards the earth under gravitational force is called free fall. That means when some object falls freely on the surface of earth. Suppose this is an object, okay, and it is falling on the surface of earth. Okay. Suppose it has a mass m1, and let us denote the mass of earth with capital M, okay, because that is very much. Okay. So, mass of the object is m1. It is falling towards the earth. So, which force is actually attracting it? The gravitational force. The gravitational force applied by whom? Applied by our earth. And that force is also called as force of gravity. What do we call it? Gravity. The force applied by earth on any object above it is called force of gravity. Okay. Now, my question is that if the object will fall down, will its speed gonna increase or decrease? Suppose if you are dropping a stone from a wall, okay, and suppose you are dropping the same stone with a tower on a tower which is like 10 story long, 10 मंजिले बिल्डिंग से अगर सेम पत्थर को हम गिराते हैं, when it will strike the surface, जब वो टकराएगा, तो किस केस में उसकी स्पीड ज्यादा होगी? जब ज्यादा ऊपर से गिराने पे, राइट? So definitely when we drop an object, suppose if I have something in my hand, suppose I have a pen in my hand. Okay. When I am releasing this pen, the moment I release this pen, the force of gravity will work on it. Definitely. See that? Yes. But when we just left it, when we just released it, its speed was zero, right? But as it is going down, it gains some speed. There is some change in the speed. Why there is a change in the speed? Because there is a force. And you already know that every force creates what? Acceleration. Very good. So which force is acting on this? The force of gravity. Gravitational force is acting on it. Who is applying this gravitational force? Earth is applying this gravitational force. Okay. Now, when any body falls down freely in the influence of Earth's gravity, we call it free fall. Okay. And when a body is undergoing free fall, there is an acceleration which will be produced, and this acceleration is due to Earth's gravitational force. And we call that acceleration is acceleration due to gravity, and we denote that acceleration with g. So whenever something is falling with under the force of gravity, it will experience a acceleration that is represented with small g. So if someone asks you what is small g is the acceleration due to gravity. Okay. So suppose this man have a mass of 50 kg. Okay. How can you find the force of gravity acting in it? So if we know the mass and if we know the value of g, we can calculate the force acting on an object. Now, in many of the books, it's mentioned that the acceleration due to gravity have a fixed value. Okay, that is 9.8. Okay, what should be the unit? If it is acceleration, the unit should be क्या होगा? Meter per second square. Yes, because this is the unit of acceleration. Okay. Now, in many of the cases, I have seen that for the simplicity of the calculation, to calculation को easy करने के लिए, किसी किसी बुक में gravitation, the acceleration due to gravity is also taken as 10 meter per second square. क्यों? ताकि आपका कैलकुलेशन इजी हो जाए. Yes. So let's move ahead. So what is free fall? You already know, when any falling object, any object falls from a height towards the earth due to the gravitational force, it is called free fall, and such body is called freely falling body. Okay. Now, when we talk about freely falling body, okay, suppose there is a stone. Let's first suppose over here. Suppose, okay, there is a stone, okay, a stone of mass 1 kg, okay, and I have dropped it from a height of 20 meter, okay, what? Height of 20 meter, okay, and it is falling towards the surface. Okay. If I ask you how much gravitational force is acting on it, so you will say ma, but this is the force due to gravity. So here we will replace this ma with with g. Yes, good. We'll replace this a with g. We'll say F equals to mg. Now in the question, or if I say what is the value of g, you will say that's an for, like, if it's not mentioned, you will always take the value of g as 9.8. Mass is 1, g is 9.8. So how much force the body is experiencing, the stone is experiencing? It is experiencing a force of 9.8 Newton. Okay. Now my question is that how much time it will take. Now, when we talk about time, that means we are talking about its motion, how it's moving, how much time is taking. Okay. So we have discussed three equations of motion. Do you remember? What was that? Equation of motion says V equals to ut plus at. Now, if we talk about gravitation, we will replace all the a's, because this a means acceleration, and if we are talking about gravitation, we will replace this acceleration with acceleration due to gravity. So the equation that we got is V equals to u plus gt, s equals to ut plus half gt square, and v square minus u square is equals to 2g. Okay. Now basically s is considered as horizontal distance. Okay. And when we talk about vertical, if something is falling from a height, it will fall like this or it will fall like this. Definitely not this. Okay. So we call that distance as h. So yes, the s will also be replaced by h. Okay. So we are replacing this with h. Getting it? So these are the equations of motion that you will use in terms of gravitation. Okay. So now the question here is that when we take let's take the example of this question. So how much distance it is covering? The height is 20 meter. Okay. What is the velocity? What is the initial velocity when you are dropping this object? When you drop something, it does not have any velocity. It has a zero velocity. But gradually when it goes down, अब धीरे 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 उसकी स्पीड बढ़ती जाती है. ओके. सो स्टार्टिंग में कोई स्पीड नहीं, जीरो स्पीड. सो इनिशियल स्पीड और इनिशियल वेलोसिटी इज जीरो. नाउ व्हाट वी हैव टू फाइंड? We have to find the time. What else we know? Do we know the value of acceleration due to gravity? Yes, we know that. Okay. What we need to find? We need to find the time. So come on. Do we have any equation that have time? Okay. Let's talk about this second one. And this we can use all of them. Okay, and we can find time. First one we cannot use because we don't know v. Second one, yes, we can use it. So it is h equals to ut plus half gt square. Now, what we have to always keep it in mind, because we already know that force, displacement, or velocity all are vector quantities. So we have to be very careful about the direction. Okay. Now, direction. Height is 20. U is 0. So that is why the product of ut would also be 0 plus half g. What is the value of g? 9.8. Now look at the direction of g. Where does the gravity acceleration due to gravity work? It works in the downward because it pulls the body downward. So the acceleration due to gravity will always act in downward direction. Okay. Now, what is the movement of body? Is body is also moving down? Yes. So definitely g means the acceleration and body are in the same direction. So we will take the value of g as positive. Okay. Because both are in the same direction. If body is going up, but g, if suppose the body is going up, g always works down. At that time, we will take g as negative. But now, यहाँ पे हम g को पॉजिटिव लेंगे, क्यों? क्योंकि बॉडी भी नीचे आ रही है और g भी नीचे ही लग रहा है. ठीक. टाइम टाइम पता नहीं. टाइम पता नहीं. ओके. So let's talk about it. 20 is equals to, इसको काटो, 4.6. Okay, 4.9. Yeah, 4.9. Okay, into t square. How to find the value of t? So t square is equals to 20 divided by 4.9. And if you want to find the value of t, you have to do the square root of this. Now, this is why in many of the question, g is also mentioned as 10 meter per second square. Why? To make the calculation simple. If this would be 10, then the answer would have been 2 seconds. Okay. So if it's not given, we'll take it as 9.8. If it's given, we will take it 10. Okay. So if anyone asks what is the actual value is 9.8 meter per second square. Okay. So these are the equation of motion. You will have to keep it in your mind. Let's do some other question. Okay. On the same topic. Okay, on the same topic. A car falls off the ledge. Oh my God. गाड़ी गिर रही है भाई, यहां से गाड़ी ऊपर से नीचे गिर रही है. कितना टाइम लगा गाड़ी को गिरने में? Okay, let me make a car. Okay. I don't make a good car, but though I can try. Okay, this is a car. Car is falling off the ledge. Okay. It is falling down. That means how much time would it take? It would take 0.5 seconds, or I can also say 1 by 2 seconds. Okay. It's already given g is equals to 10 meter per second square. What is the speed on striking the ground? When it was falling, it might be moving this or this, but it was not moving down. So at the starting, when it started falling down, whenever we drop something and whenever we release something, its initial velocity is always 0. Yeah, the velocity keep on increasing. We don't know the final velocity, but initial is always 0. Okay. Now we have to find v. Is there any equation that will help us? So let's take v equals to u plus at. We can use u. We can use, okay, a is g now. Okay, g and t. Yes, we can use them and we can find the value of v. Come on. 0 plus 10 multiplied with 0.5. That is, v is equals to 5 meter per second. First question done. Answer is 5 meter per second. So with this speed, the car will hit the ground. Okay. With this speed, and what was the initial speed? 0. Okay. Next, what is the average speed during 0.5 second? What is the average speed? So we can only calculate the average speed when we know the distance. Yes. So come on, let's find out the distance first, or let's find out the height. Okay. So I'm doing the calculation over here. Height. Is there any formula that for which we can use height? Yeah, there is. H equals to ut plus half gt square. Okay. We know u is 0, so this would be 0 completely. Half. G is 10. Time is 1 by 2 into 1 by 2. Why? 2 times because it's square of 1 by 2. 5. Height is what? Height is equals to 5 by 4 meters. That is equals to 0.125. Or you can also say it's 125 centimeter. So it's not covering too much of distance down. Okay. If we talk about meter, we will take 5 by 4 for the sake of simplicity. Okay. I think this was the third question. How high is the ledge from the ground? So ledge is only 5 by 4 meter higher from the ground. This is the answer of the third question. And if we got the distance, we got the total distance. Come on, let's do this. We have to find the average speed. Do we remember the formula for the average speed? याद है कि नहीं भाई? Yes, total distance upon total time. चलो बताओ जल्दी. डिस्टेंस है 5/4 और टाइम लग रहा है 0.5. 5/4 is the distance and 0.5 is the time. So 1 by 2, 2 यहाँ लिख दें. Okay. 2 ones are 2, 2 to the 4. Answer is 2.5 meter per second is the value of एवरेज स्पीड. एवरेज स्पीड हम ऐसे भी निकाल सकते हैं जहां पे भी एक यूनिफॉर्म एक्सेलरेशन है. एवरेज स्पीड निकालने का फॉर्मूला है u प्लस v बाई टू. u हमें पता है 0. v अभी हमने निकाला था लास्ट क्वेश्चन में 5 और डिवाइडेड बाई 2 दैट इज 2.5. एनी हाउ द आंसर इज सेम. ओके. सो दिस इज ऑल अबाउट दिस क्वेश्चन. लेट्स मूव अहेड. So here we came up with a very interesting topic that we are going to discuss in the second part of gravitation. So what we have discussed till now, we have discussed about a lot of things, a lot of things. Okay. We have discussed about universal gravitational constant. Okay. Let me just list all the things that we have discussed. We have discussed universal law of gravitation that gives us a very important expression. Okay, what is that expression? The expression is F equals to G m1 upon into m2 upon r square, where what is m1 and m2? Masses of the object. What is r? Distance between the object. Let me write it over here. Masses of object, and this r is the distance between them. You can also say distance between them, or if it's a bigger object like Earth, Sun, any planets, okay, we can also call them distance between their centers. Okay. What is G? G is universal gravitational constant. Good. And what is the value of this? G. 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay. Then we discussed about its importance. Then after that we have discussed about free fall. Free fall. Free fall means a body falling down towards the surface of Earth due to its gravitational pull. Okay, that's called free fall. Whenever a body undergoes free fall, it experiences an acceleration. What do we call that acceleration? We call it acceleration due to gravity. Okay. Now we will also have a quick discussion about small g and capital G in our next class. Okay. So this is what we have learned about gravitation. You can follow the series to get more and more videos. Like in next video, you will be covered with mass and weight, how this value of G depends, what is the difference between mass and weight. You also think about it. Okay. So see you in the next session. For more such videos, stay tuned to this playlist, this series, which is called uh, Grade Ninth Complete CBSE Syllabus Series. Okay. This is gravitation. We will be covering more topics in part two of gravitation because it's a very wide chapter and it has a very uh, it needs a lot of understanding. So we'll do it slowly, slowly every day. Okay. So bye bye, my dear students. We'll see you in the next session. Okay. Take care. Bye bye. Don't forget to share this link, the channel to your friends. Okay. Or anyone who needs it. Okay. So this is it all about that I was trying to share. Okay. Now let's come back to the main page over here. So this is your YouTube channel that where you can get all the exclusive contents related to science, teach AR, share this on WhatsApp, Instagram, wherever you can. And please do comment if you want any specific topic to be covered. So signing off. Bye bye. Take care.